Challenge activity 8.1.2, hypothesis testing for two populations mean, right-tailed t-test. A real estate agent believes that the mean home price in the northern part of a county is higher than the mean price in the southern part of the county and would like to test the claim. A simple random sample of housing prices is taken from each region. The results are shown below. So one thing that's really important here is that this is an independent or independent test. We don't care about linking one specific house to another one. The reason for that is that we're just looking at overall cost of the southern compared to the overall cost of the northern. So it's important to recognize when you need to do a paired t-test versus a unpaired t-test or independent test. So let's go ahead and find our values. So first we're going to find the p-value, not the proportion p, the p-value. I will keep reiterating that because that is definitely something that needs to be addressed. So that right here, we're going to pull from our one-tailed test, 0.03. So we're going to 0.03. Our test statistic T is right here. It's 1.949. Our N, now listen, this is where it gets a little bit different than what we looked at before. Here we have, so we're not linking them. So we have 18 from our sample, our southern sample, and 18 from our northern sample. That means our N is actually 36 observations. In an independent t-test, our degrees of freedom is actually N, this N, minus 2, because you have to subtract 1 from each one. So it's actually going to be 34 degrees of freedom. Our point estimate is going to be that mean, that X bar. So here we have southern, that's 155.056. Oops, helps if I type it correctly, 0.056. And our X bar is that, for the northern is right here, that 168.889. 168.889. Let's go ahead and check our answer. There, green little check. A maker of dietary supplements would like to claim that a new supplement increases performance on an IQ test. IQ tests are administered to a simple random sample of people taking the supplement as a treatment and a control group. The results of the study are below. So one thing we need to do is first decide what our population parameters. So we're not looking at the difference in the sample sizes or the difference in the two sample means. We're actually looking for the mean score for all test takers in each of the two groups. Is the two sample hypothesis a paired test or unpaired test? It is unpaired because we're not linking one specific observation from each of the groups. We're just looking at the mean in each of those two groups and comparing the mean from before the treatment and then the control group. Because again, you have, in this case, you have two different groups of people. You have a group that just, the control and then the treatment, sorry. The level of significance, we're going to go to confidence level. We're going to take that 100 minus 99 gives us 1. When we convert that to a decimal, we get 0.01. What is the null hypothesis? It's always that the mean 1 equals mean 2. What is the alternative? In this case, our treatment group is population 1, control group is population 2. So we're looking to see if mean 1 is greater than mean 2. Should H naught be rejected or does H naught fail to be rejected? Well, let's look at our p-value. It's 0.479, which is quite a bit bigger than our level of significance, which means that we failed to reject the null hypothesis. And when we fail to reject, we say that insufficient evidence exists to support the claim that the mean score of the supplement group is higher than the control group. Let's check our answer. Look at that nice little green check mark right there. All right. That's how you do challenge activity 8.1.2. If you have any questions, let me know.